one of the advantages that we mentioned about online learning to rank compared to counterfactual learning to rank or the traditional learning to rank that uses relevance labels is that online learning to rank methods are responsive to changes of intents. That is, they immediately respond to what the user intends for a query, what he finds relevant for a query. So let's try to visualize that a bit and understand a bit better. So here in this plot, on the y-axis I show NDCG as usual, so that's performance of the ranker. On the that's the y-axis, and on the x-axis I show the number of impressions, so how many search engine results the user sees. And however, unlike in previous plots that I showed that are similar to these, in this plot, after every 50,000 interactions, 50,000 search engine result page, the user changes the intent, so changes what he believes is relevant for the specific queries. So say, for example, the query was US president, and from 0 to 50,000, the user finds pages about Donald Trump as being relevant, and from 50,000 to 100,000 impression, he finds pages about Biden to be relevant. So what the intent of that query, finding pages about Trump versus finding pages about Biden, that intent has changed. And we have these changes every 50,000 impressions. So in this case, we have 4 different intents that they change. Now, we have 2 types of rankers. One is a ranker that has been trained with the intent since the beginning of the interaction, so since interaction 0. So that's the purple ranker, right? There is a single intent. And then it's the aqua ranker and the red ranker and the green ranker. And for example, for the red ranker, that's the ranker that has been trained with intent 3, with assuming that what is relevant is what intent 3 says from iteration 0. Okay, so the performance of the ranker for intent 3 are shown just between 100,000 and 150,000 interaction, but that rank has been trained since interaction 0. And then the other ranker that is shown is the current, the ranker trained with the current intent. So that ranker is trained with intent 1 during the first 50,000 interaction, and so that ranker is the same as the fixed intent for intent 1. But then for intent 2, the ranker that was trained with intent 1 up to 50,000 interaction is now trained with intent 2. And so that's the dark blue line there. And once we arrive 100,000 interactions, the ranker that was trained with intent 1 for the first 50,000 interaction, with intent 2 for the second 50,000 interaction, is then trained with intent 3 for interaction between 100,000 and 150,000, and similarly with intent 4 from 150 to 200,000. Okay, so now what we see here is that there are differences between the ranker trained with the intent that is current at that point in time and the intent the ranker that was trained with the intent in that point in time since the beginning. So that's the gap between the blue line and the aqua line, the gap between the blue line and the red line, and the gap between the blue line and the green line. And as you see, the ranker that is trained with the intent that is current will drop in terms of performance, right? And so by what we see here is that when an intent changes, the ranker drops in performance, But then the rankers improves as impression are observed, and it improves to often reach the ranker that was trained since the beginning with the intent, the specific intent in which we are looking at, for which we are looking at, right? Sometimes it doesn't arrive to that score, but eventually would arrive if it had more interaction. So these example here shows how online length rank indeed does adapt to changes of intent, because every time an intent change, your ranker drops in performance, but then as it keep observing clicks generated by this new intent, the ranker will change itself and will adapt to that intent that the user is now referring to. It wasn't in the past.